So they had a book sale at a local library. I mean, it's not a book sale like a one-time event, but they were selling books there. And hardbacks this time were 25 cents a pop. This book is The World Treasury of Physics, Astronomy, and Mathematics. A book like this would cost like, what, 30 bucks? But Annie J. Cannon on page 272, I have a few issues with this. She had to publish her essay anonymously because clearly, women weren't accepted in astronomy as much as they are today. So this essay was written in 1929, and one thing I noticed about it, well, a lot of things I noticed about it. I'll read this out to you guys. The very beginning of our knowledge of the nature of a star dates back to 1672, when Isaac Newton gave to the world the results of his experiments on passing sunlight through a prism to describe the beautiful band of rainbow tints produced when sunlight was dispersed by his three-cornered piece of glass. He took from the Latin word spectrum, meaning an appearance. The rainbow is a spectrum of the sun. And clearly, if you look at spectrum, the word meaning an appearance or apparition, and then you combine that with the very ancient fable or knowledge that appearances can be deceiving, you get one of the most incredible understandings ever. And the reason why it's an incredible understanding is because these astronomers back in the 20s, they began classifying stars based off of their appearances. What they appear to be is the name of the game in the 20s. And for some reason we kept the appearances. And that being said, the reason why they kept the appearances, regardless of, they're clearly being deceived, was right here on page 273. It might have been expected that the sun, our parent, would contain the familiar earthly elements, as we were certainly in a distant age bone of his bone and flesh of his flesh. That being said, it was believed in the 20s that Earth came from the sun, or at least the Earth, Jupiter, Saturn, Uranus, Neptune, and every single moon and asteroid in the solar system, all are remains of the sun being born. And that just simply isn't true at all. But what happened is they had planets and smaller objects other than stars as being byproducts of stars being formed. But what they actually are is byproducts of stars evolving. They're ancient stars, or impact remains. That was pretty interesting. 1929. And here's another statement here. After a large number of stars had been classified, and keep in mind, Annie J. Cannon had classified 250,000 stars, so by their spectrums. So she was pretty convinced that only the things that shined were the stars, I guess. I guess that's how you could say it. I don't know. I'm not sure if that's correct, but she assumed that only that the stars could shine. How do I word this? That only the objects that had spectrums could be stars. They can't be planets. So she had classified them distinctly in her mind at first. And you can see that here. After a large number of stars had been classified, it was found that the letters B, A, F, G, K, M stand for 6 divisions, including the great majority of the stars. The truth is, the ones that are visible are not the great majority. The great majority of stars do no longer shine. They're dim. They're essentially burned out. A lot of the material, the plasma, is transitioned into gaseous matter, and it stops shining. The gas giants. And the gas giants, even bigger increasing numbers, are the rocky objects the gas giants form in their interiors. So we have multiple stages of evolutionary structures, and they've classified just the beginning parts of it. And then they assumed that only the beginning parts. They drew up entire evolutionary models based on the beginning parts of these stars only. So they just went off on the deep end. And I think it's real funny on page 275. She writes, "This is not a fairy tale, I am telling you." Check it out. This is not a fairy tale. Thought that was interesting. You gotta believe me. I'm telling the truth. But and I didn't notice that she had mentioned the second law of thermodynamics anywhere in there. But if astronomers had paid attention to the laws of thermodynamics instead of trying to force their belief that Earth came from the sun or was born from the same material, they would understand that stars cool and lose enthalpy and entropy for the most part, and become like Earth over many billions of years. And the second law of thermodynamics goes like this. If you have two areas that have different enthalpies, you'll have the one with more enthalpy go to the other one and even out. So they match each other. With stars, given its its isolated system and no other energy or mass is added to it. With stars, you have objects that are 2,000 degrees Kelvin and above. But with astronomers, since they only classify stars as being the ones that have visible spectrums, they can safely ignore all the stars that are below 2,000 degrees Kelvin. Or even 500 degrees Kelvin. I think there's one star listed as that on the exoplanet catalog. But anyways, I wrote a little sheet here. Says, big ones. And then you have outer space is what, 2.75 Kelvin on average? Of course, if the second law applies to just rooms in your house, evening the temperature out, why would it not apply to stars in outer space? So you have 2,000 degree Kelvin stars equaling out to the temperature of outer space, which is 2.75 Kelvin. Clearly, there's a motivating factor for the star cooling and shrinking as it loses mass and energy. But that isn't included because you can't classify a star based off of its temperature if it's below a certain threshold. Because you can't even see the damn thing. If Annie Jump came and knew that, then we wouldn't be in this predicament. Stars want to reach equilibrium with their environment. As well, the isolated system is the universe itself. Which also brings me to another important fact. And I didn't know this at first, but it was shocking to really learn, to really comprehend what it meant. But the status quo, what astronomers believe, the status quo, what everybody believes to be true, the paradigm, that will always rank above even laws of thermodynamics. Inside of academia and mainstream researchers. As dissidents, they don't have to worry about that. But the mainstream researchers and the academics, status quo will always rank above laws of physics. And that may sound absurd to them, but I can see it for myself because it's true. And the reasons why it's true is because they have peer pressure to conform. They work inside of conformist institutions. There's consequences due to nonconformity. And those consequences are loss of pay, loss of benefits, loss of status, and inability to publish papers. They'll blacklist you. They'll refuse your publication, say, oh, well, that information is wrong. You got to go through the peer review system now. And the peer review system is essentially the conformist society's way of saying, hey, you're full of shit. You got to accept what we accept or else. But that being said, if you apply the second law of thermodynamics to stars, you clearly find out that stars and planets are the same objects. You have the hot young star cooling, and the enthalpy will want to even out with outer space, which is an environment, so it will cool. It will become a gas giant, and then that gas giant will continue cooling and deposit the material into its interior, making the rocky planet. And we also know that they ignore a whole lot of stuff, but they ignore it. Here's a printout of the Open Exoplanet Catalog. This is kind of dated. They changed it now, but you'll still find similar information. They have one star listed at 2100 degrees Kelvin. They skip an entire 1600 degree Kelvin gap and go straight to the one that says 540. I don't know if I have that on there. I'll link this to the bottom. But they have a huge gap of temperatures there. Where the fuck did those objects go? What are they doing? What they're doing is they're trying to force the information that they see, that they observe, to conform to the paradigm. That's why they ignore all the stars in between that gap. Like I said, status quo ranks above laws of thermodynamics. Laws of physics, status quo is numero uno. You have to do what everybody else is doing, or else you don't get hired, you don't get the money, you don't get the Nobel Prizes, you don't get all the good stuff. And it's kind of sad if you think about it. People, they can be easily swayed, they can be convinced with cash. It's that simple. Later, y'all.